So I'm doing this from home. My home computer was on. So welcome, Flora, and welcome, Lamar, and Robert, and Kyle, and Mizard, and iPhone.
Sabrina, sorry, hi.
Irina, okay. Welcome, all of you. Again, I apologize for being a little bit late, but I was on time, and then I realized it was not working at the college, so I had to do this at home because I had this going at home, and it won't allow me to do both places. So let me start out by reminding you, you should be getting into your project at this point. So at this point, the hope is you all have a project topic and you have an idea on how you're going to decide on who you're going to survey, either using stratified sampling or using a cluster sampling technique. You could do either, but you have to do one of those. And if you don't completely understand it, that's where you ask me, and I'll help you out. If you haven't already done it, I know some of you have, be sure to post on the project discussion forum your topic idea. And I also recommend that you take a look at the conversations that have happened in the project discussion forum in the last week or so, and then you'll get some ideas on what other people are thinking about, and also what they thought about, and then what needed to be adjusted, so that you don't make the same errors that you've seen. That's one of the main reasons why I ask you to put it on the project discussion forum instead of emailing me. So if you try emailing me, I'll say post on the discussion forum, and that way other people can benefit from the conversation, and you all can kind of see best practices. And that's what I'm here for, is to help you with best practices for conducting research. Because I don't know if you've realized, but that's what this class really is all about, is how to conduct research with data. That's what it's about. So let me stop and ask you, are there any questions about anything before I go on? And as I do that, I am going to open the files that I emailed myself from the college. Download, open. The one thing I don't have on this computer is the calculator. So I'll do it with a spreadsheet. And it'll be nice. You can see the spreadsheet really does everything. Let me get a couple things going. While you're thinking about questions. So any questions? Any questions at all? It's a little harder because I'm doing it from home. I don't have the double screen. I just have a laptop. But I'll be able to figure it out. So are there any questions? Again, anytime you have questions, just like always, feel free to ask anytime. That's what these webinars are about, is it allows you to ask questions real time instead of just kind of guessing at it. I also need, where is it? I did not expect, oh shoot, wrong one. That's the work. I did not expect to be doing this from my my work computer and my home computer. So it's not quite as set up as I was hoping. As you guessed, fortunately I live real close to campus, so I was able to bike over here within not too many minutes. There we go. And let me pop this in just 1 minute. And what we're going to do is we're going to do examples. We're going to work through some questions that involve chapter 4 and chapter 5. So right now I am just setting it up, and then I can show you what's all there. There we go. All right, now I can share my screen, hopefully, in a moment. This is actually the first time I've ever taught using this computer. I did the orientation webinar, but that's different. There's no teaching involved. So let me share my desktop. Okay, so the first thing is in chapter 4, we're going to deal with discrete distributions. Discrete distributions are really important. They are distributions. First thing, they're quantitative. And do you all remember what quantitative means? It's really important for the project, for example, because if you don't have if you don't know what quantitative is, you could go really badly wrong on your project.
Numerical versus descriptive?
Yeah, numerical versus not numerical. Yeah, so numerical versus descriptive is good. But they're a little more than quantitative. So there's two kinds of quantitative. Discrete is one of them. And discrete means you can list all the different possible answers. Whereas continuous means you can't list all the possible answers. So for example, all the numbers between 0 and 1, that is continuous because you can't list every number between 0 and 1, right? All the fractions and decimals, you just couldn't even approach listing them. Do you all agree with that? Okay, but if the survey question was something like, how many siblings do you have? You could list all of them, right?
Yes.
Right? I have, in my family, there are 4.5 siblings. Okay, I think I might have mentioned that before, right? Okay, so it's a little review. So the first chapter is on discrete distributions. Because you can list them, it means we can actually put them in a table. And so let me read out the question, and then I'll go ahead and we'll create a little table. That's the plan. So the question is, a car salesperson gives out a $10 gift to every customer who test drives a car. Isn't that a typical thing that happens in a car dealer, is they give you something and then they hope you buy, right?
Right.
Okay, let's suppose 12% of the customers who test drive a car purchases the base model of the car, and the salesperson gets a $200 commission. Okay, 8% of the customers purchase the deluxe model of the car, and then the salesperson gets a $300 commission. Okay, more money if they can sell the bigger stuff, right? So what we want to do here is we want to write down the probability distribution function for the salesperson's profit and find the expected value and standard deviation. And interpret the expected value. And then, is this a lucrative job? I know in my other class, my face-to-face class, not everyone knew what the word lucrative means. Do you guys know what lucrative means? Anyone not know? Okay, I'm going to assume you do. Okay, so what I'm going to do is I'm going to draw a table. So I'm going to make a little table doing this, and let's go ahead and draw a table. So it's a t-table. And you can either draw it horizontally or vertically. I'm going to draw this one horizontally just because space reasons, it's a little easier. But sometimes you draw a t-table that's a vertical one. You've all seen tables in math, right? And then what I'm going to do is I'm going to make the first row, or if you're going to be doing it, by the way, you could do it row or column. It's your choice. And I'm going to call that X. Let's try this one more time. It's having trouble. Just a minute, one more try. There we go. So I'm going to call that X. You're used to that in a t-table, right? Hopefully, in math. So I'm going to call that X. Trying to make that a little higher. There we go. And then the second row, or you could do columns, I'm going to call that P of X for the probability that X occurs. Any questions so far? All right, now let's see if you can tell me what are the different things that could happen? What's the different amount of profit that the car salesperson can get? What are some things that could happen? So what's the profit that could happen? Even the cat knows.
$200.
What's that?
200.
Okay, close. But remember that the car salesperson gets $200, right? Did he have to pay anything? Or she?
No.
Think about it. What's the first thing the car
$10 gift
salesperson's
card.
doing?
The $10 gift card.
The $10 gift card. So what's the profit for the salesperson?
190.
190. So all of you business majors, and I never remember who got what major, but I know we had some business majors, is profit is revenue minus cost. Do you remember that? So the revenue was your 200, the cost was $10. So what I'm going to do is for my first value of X, I'm going to put in 190. What's another thing that could happen? What's another amount of profit that the car salesperson can make? And now,
290?
290, right? Because that means that the luxury car was sold, and she got 300 and had to pay 10, and that's 290. Is there anything else that could happen? Here's a hint. What do most customers end up doing?
Nothing.
Right. If the customer doesn't buy a car, then what's the profit for the salesperson?
Negative 10 or 0?
I liked your first guess first.
Negative 10.
Yeah, because remember, it's revenue minus cost. Revenue is 0. Cost is 10. 0 minus 10 is negative 10. Any questions on the X values that could happen? Okay, now what we do is we find the probability of each of those things happening. What's the probability of the car salesman or car salesperson profiting $190?
12%.
Yeah, but you want to write it as a decimal.
So 0.12.
Yeah, so 0.12 will be our first probability. Is that clear? Okay, the reason why you want it as a decimal is we're going to be doing calculations with it, and percents don't work well on a calculator with calculations. Does that make sense? Calculators like decimals. All right, so now what's the probability of profiting $290?
0.08.
Yep, 0.08. What is the probability of profiting negative $10?
8.8.
Yeah, 0.8. So notice that when you add up all the probabilities, you always have to get 1. So if you're on the very last one, you don't know it, you take 1 minus the sum of the others. So 0.12 plus 0.08 is 0.2. 1 minus 0.2 is 0.8. Any questions on that? Okay, the bad news is because I'm at home, I don't have the calculator on the computer with me because my computer here doesn't have that calculator screen. But I will guide you through it. I'm going to do it on the spreadsheet. I just got to remember 190, 290. I think I can remember. It's negative 10, 12, 12%, 8%, and 80%. So I'm going to show you on the spreadsheet, because you can do it on the spreadsheet too, by the way. You're allowed to use a spreadsheet for everything except for the midterm and the final, by the way. So I have the spreadsheet because that I can use. But first, I need to stop share and reshare. And the spreadsheet is what you use for your project. So what I'm going to go is I'm going to go to compute. Sorry, not compute. This is 2var_stats. I'm going to highlight the first and second, hit backspace. On the first, we had 190, and then we had, was it 290, right?
Mm-hmm.
And -10. And on the second, we had 0.12, and then we had 0.08, and then we had 0.8. If you're using your calculator, you're going to do what I did in L1 and L2, and then you're going to go stat, and then you're going to go to 1var_stats, and then for the older version, you're going to type in second1, second2, and then enter. For the newer version, after doing 1var_stats, it's going to ask you what your variable is. I forget what the label is, but the very first thing, and that's L1, and it's going to say freq, F-R-E-Q for frequency, and that'll be L2. And then you hit enter twice. Okay. Spreadsheet's actually easier. I bet some of you didn't even know the spreadsheet does everything, but it does. At least I tried to make it do everything. Almost everything. There we go. It's got to put all your pictures up higher so I can get to it. So now what I need to do is I need to move it over and see it says stats as frequency table or expected value. There we are. So the mean is 38. That's the expected value. Standard deviation is about 98. Any questions on that?
Yeah, can you just tell us one more time how to the calculator? I have it punched into L1 and L2, but I just want to make sure for the sake of the exam that I know how to do this on the
Okay, you go L1, you put in L1, you put in L2, then you hit stat, then you go to calc, and then you go to 1var_stats. And then from 1var_stats, it depends on which type. There's two types of 84 calculator. It's kind of a pain. One type, you type in second one for L1s, second two for L2, and then enter. The other kind, the newer kind, it'll give you a menu, and under the variable you type in L1, or make sure it says L1, and under freq, you go L2. And that's
cool. This is like weirdly specific, but where's the comma button?
Comma is, I'm trying to remember, I got to do it by memory. You take all the numbers and it's above the top numbers.
It should be above the 7.
Oh, there it is.
Above the 7, yeah. Okay. Like I said, I'm trying to do by memory, so it's above the top numbers, above the 7.
All right, I got you. I'm caught up. Thank you.
Okay, good, good.
I have a question.
Yeah.
So on the calculator, we're doing 1 variable statistics, and then on a spreadsheet, you're doing 2 variable statistics?
Yeah, and that's just the way it is. It's spreadsheets are a little different than calculators.
Okay.
You know, as long as you know how to do it, that's the important thing. The spreadsheet's fine for your homework, the weekly assignments, but for your midterm, you have to have a calculator.
Yeah. Okay.
And for your weekly assignments, you could have either. So if you have the calculator, just use your calculator.
Okay.
But since I don't have the calculator on the screen, I can't do it with you on that. And that was the disaster that happened at the college. I don't know. Did you come late or not?
Yeah, I came in.
Okay, so you didn't know the reason I started late because I was at the college and this computer was on another meeting I had. I let everyone else finish the meeting while I ran to the college to do some work. And then I realized that I can't have both on at the same time.
Okay. Gotcha.
Because this was basically not letting me do anything. So I had to bike back home and start. So unfortunately, I don't have the calculator on this laptop computer.
Okay.
The funny thing is I have it like here in front of me, but that's not going to help you guys. Okay. So now let's interpret. Interpreting is really, really important. So let me, so we have 38 and 98, let's call it. Okay, so here we are, and it's time to write down the interpretation. So first thing, we found the expected value was 38. Now let's write down what that means. So what this means is that so kind of the template is if many trials are done, then it's very likely that the observed average will be very close to the expected value. So now we got to turn that into words about this problem. So many trials means many customers. Does that make sense? So if many customers test drive, then it is very likely that the average profit, because that's what we're looking at, right? Per customer for the salesperson will be close to $38 each. Any questions on that? Any questions? I want to emphasize something, and that is the words very likely, the word average, the word close to, and, oh, sorry, that should say many, not any. Sorry about that. See if I can get an M in there. Close enough. The word many, all those words have to be in there. And then like customer, that comes from this question. Okay, salesperson, that comes from the question. It won't always be dollars. It could be other things that you're quantitative studying on. Any questions on this idea? Any questions? Okay, so in business, profit is usually the biggie. I mean, there's some other things you care about. Sometimes you care about revenue or number of customers or cost or something like that. But profit, they call the bottom line, right? But pretty much everywhere you use our expected value. Okay, it just means what is the expected average over the long run going to be close to? And that's the expected value. Any questions on this? Okay, the standard deviation was around 98. That's in dollars. Is that a high standard deviation? What do you think? Take a look. The mean is the expected value is 38. Is 98 a high standard deviation or not? Yeah. So what that says is, remember,
output.
What's that? I heard you and I lost you. Okay, so what that means is that kind of the fluctuation is up and down by 98 on average. So if you're a car salesperson, then you better not be relying on having profit on any particular day. There are going to be days that are just ugly. Okay, so you got to make sure that you got money in the bank so that you're ready for those bad days. Any questions on that? Okay, it's a typical thing that happens, say, when you invest, right? Is that if you invest in something that has a high standard deviation, that means that the amount of money that you have is going to go up and down widely. So they actually call that the risk. So this is going to have a high risk for a job. It's not a stable job. Some days you can do really well, and then some days are going to be awful. Okay, whereas my job, anyone know the standard deviation for my job? I'm a teacher.
Are you salary?
Yep.
Then there shouldn't be any deviation.
Yeah, standard deviation 0. Right? I know exactly what I'm going to make at the end of the month. Okay? But if I were a car salesperson, that's a whole different thing. Does that make sense? then you're going to have a higher standard deviation. And that matters. Okay, now think about this. Is this a lucrative job? What do you think?
I guess it depends on how long each test drive and
Yeah, how long do you think it takes to test drive a car? And to work with a customer? Anyone ever test drove a car? How long did it take you?
I think the average per, like when I was helping my brother shop for a car, it was like we would be like 2 to 6 hours at any dealership.
Test driving a car?
Yeah,
Wow.
just driving cars and like figuring out what they want because they give you their sales pitch. They try to sell you all the different models, blah, 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 blah.
So if it was 2 hours,
Mm-hmm.
if it was 2 hours, you're making about $19 an hour. Do you see that? If it was 6 hours, this is horrible. See how that works? So it depends. Again, it depends. It depends on how long it takes to work with a customer. Any questions on that? Okay, let's do another one. And we're going to do different kinds of problems. So I'm only going to do one of these kind of problems. I just want to let you know that, again, you have these long videos that are set up, but you don't get to ask questions, but you're going to see every kind of problem. So for now, I need to clear this guy and give you another problem. I want to go to select this, backspace, and let me give you one more. Okay, this one's going to be very different. I think I'm going to do this one because it'll lead us into what's going on in this class. That's a fun little problem. In a second. Okay, so here's the question. 21.2% of high school seniors have used marijuana. It must be true because I read it on Google. Okay. A study of 200 high school students in states that have legalized marijuana for recreational use found that 49 of them have used marijuana. So the other one should be B. A, is this statistically significant? And the idea is we need to find the probability that at least 49 out of 200 have tried it. That's a typical study that people would make because they might be concerned. You know, is that an issue or maybe it's not an issue? Does that make sense? Okay, so now let's do the math. Okay, easy to read and understand what it's interested in. But now what the hard part is how do you figure out the math we need to do? This is a special kind of question. First thing, what is the survey question? What are you going to ask this high school kid?
The survey question here is, have you used marijuana?
Exactly. And what are the answers that could happen?
Yes, no.
That's it.
No.
Yes or no. Right? Yes or no. I'm going to stop you there because it's just yes or no. Very important. This is a yes-no question. Yes-no questions are very important in statistics because they happen a lot. Very different than what we had just done with discrete probability, where it was lots of different answers, numbers, all that. With yes-no questions, you do different stuff. The second thing is, notice that we're asking 200 students. Each of them is going to say yes or no. And what we want to do is want to find out how many said yes. Any questions on that? So we need to find out the probability that at least 49 of them out of 200 have tried it. Any questions so far? Okay, so the first thing, a lot of people have trouble with this, is what inequality in math is the word at least? Is it less than, greater than, less than or equal to, or greater than or equal to?
Greater than or equal to.
It's greater than or equal to. I want to emphasize that because I see that mistake a lot on tests. So at least means greater than or equal to. Okay, so don't make that mistake of thinking it's not that. Okay? So that's the first thing, is we want the probability that is greater than or equal to 49. So I'm going to do the following. I'm going to just write down some numbers. Just humor me. And I'm going to write down 48. Actually, ... 48, 49, 50, ... Okay, which numbers are at least 49?
49 and 50.
Yeah, 49, 50, and the ... after that, right?
Right.
I'm going to circle those. I'm doing this because a lot of people have trouble with this. So I want to show you that it's not as bad as it looks. If you do it this way, you'll get it right. If you do it the other way, you might get it right. The other way is just kind of thinking about it. Is at least 49. Is that clear? Okay, now if you're using the calculator, which most of you are going to be using the calculators don't do numbers to the right. They only do numbers to the left. So there's a little rule from chapter 3 that if we want to find out what the other side is, what do? What the probability of 49 up is when we only know down, what do?
1 minus that.
Exactly. So now let me write this down in symbols. So I can write down the probability that x is greater than or equal to 49 is equal to 1 minus the probability that x is less than or equal to what number?
$40.
40 something.
49.
Okay. If you do 49, then you're including 49, but we don't want to because 49 is in the circle.
So 48.
48. Yeah. That might be what you said, but I might not have heard it. Sometimes the computer's not perfect. Any questions on that? Is that clear so far? Okay, so now what we need to do is understand that this is going to be called a binomial distribution. Let me write those words down. So that's called a binomial distribution. Binomial distributions come from the yes/no survey question. And when there are many people asked, it needs to be independent. So if you hear one person's answer, the next person isn't going to change their answer because they heard. That's the main thing. But basically for the yes/no question, binomial distributions are going to be how you figure that out. And when you have a less than or equal to on your calculator, it's going to be binom CDF. And just a note, because I don't know if I'll have time to do an example of this, but if you have an equal, we're going to do binom PDF. Any questions on that? And we'll see that, you'll see that in your calculator. I can't show it to you, but I can describe it. I'll do it on the spreadsheet, but I can describe it as you're putting in your calculator and show you exactly what to do. Any questions on that so far? So let's find the probability that x is less than or equal to 48. Okay, notice, by the way, 21.2% of high school or seniors have used marijuana. In your calculator, that's P. And again, you never use percents, you use decimals. Any questions on that? So 0.212. Okay, 200 students were surveyed. So that's N. Any questions so far? Okay, so now, again, we have, see if I can remember it, 0.212, 200, and we're looking at 48. So I'm going to do it on the spreadsheet, and I'll talk you through on the calculator as I go. Just got to remember these numbers. So help me remember. 0.212, 200. Unfortunately, I'm not at work when I have two screens. I can't see. Okay, so I got to reshare. And let's go ahead and share that spreadsheet again. I'm going to go to compute, binom, N was 200, P was 0.212. And the way I did the spreadsheet is lower bound here is 0, and the upper bound was 38, right? Okay, so in your calculator, you're going to go to the binom, and that is going to be second distribution. I think it might say DIST, it might say DISTR. I forgot how many letters they use. Do you see it on your calculator? And then you're going to go to prob. Use the right arrow until you see, oh no, sorry, no prob. Sorry, different one. Then you're going to go down a lot until you see binom CDF. Do you see it? Hit enter. And depending on when your calculator was built, if it's the old style, you're going to remember alphabetical, NPX. So N, comma 200, 200, comma 0.212, comma 38. If you have the new style, it's going to ask you what N, P, and X are, and you type them in, and then you hit enter.
Is it 48?
Was it 48?
I think so.
It was 48. Yeah, sorry. I'm trying to remember everything as I go without looking. The good thing on the spreadsheet, it's really easy. That's it. I'm done. So I tried to make the spreadsheet really easy. Do you agree that looked easy? But calculator's good too. Okay. And you should get that 0.854 or so. Okay, then we do 1 minus that. So let me go back and reshare. So 0.854. So this is now equal to one minus 0.854. Any questions on that? At least I think that's what it said. Yeah, 854. And that is equal to, if I do it in my head right, 0.146. Or about a little less than 15% chance. Okay, so I want to look at the question again, and it says, is it statistically significant? So that's a new word for us. We haven't seen that before. It's actually one of the most important words in this entire class, or phrases. So the typical number you use to decide in terms of what it needs to be less than to be statistically significant is 5% or 0.05. All right, so is this less than 0.05? That should be easy for you guys, all of you. Don't need a calculator. Yes or no?
No.
No. This is greater than 0.05, so not statistically significant. Any questions on that? Okay, the reason why this is so important is whenever you see research done and it's accepted as good research, that's how it's done, is you see, is there less than 5% chance that it would just happen randomly? Does that make sense? And if there's less than 5% chance that it would happen randomly, you say, big red flag, something went wrong. So you say, well, maybe marijuana, if it was statistically significant, you would say, well, maybe marijuana states have a higher proportion of high school seniors smoking. If you have a number like 0.146, you say that's not small enough, we don't raise a red flag, and we have no idea. And it may have the fact that it was a little more than 21.2%, that could have just been randomness. And you can't say that marijuana states have a higher proportion of high school seniors smoking marijuana. Does that make sense? So that's the point of statistically significant. We're going to be doing this over and over and over again in a couple weeks. Okay, we have 2 or 3 more weeks before we get to it, and then we'll spend the rest of the quarter just doing that. But we're going to have different things besides this. But it's always going to be about statistically significant. Any questions on that? Not too bad? Okay, I don't think I'm going to do part B, but if you found out later some students lied, do you think that might happen in high school if you asked them if you smoked? Yeah, probably all of them are going to lie, right? So if you found out later and there were 54, then that could change everything. If there were 54, then 53 would be the number. And then I'm just going to quickly tell you, if it was 53, I can drop it in the spreadsheet. That's what I like a spreadsheet. It's really easy to change. And you get 0.03, and then it would be statistically significant. Any questions on that? Okay, so now we're going to move on. That was chapter 4. And that's the main highlights of chapter 4. Again, you'll get lots of examples of different types. This is just highlights. And now let's move on to chapter 5. So let me erase this guy. And we're going to go to, instead of discrete distributions, what's the other kind called? Do you guys remember? Discrete, variable, and
Continuous.
Continuous. So instead of discrete, we're going to go to continuous distributions. So one of the ways of telling if it's discrete or continuous is grammar. So here you would say, the one we just did, how many of the seniors smoked marijuana, right? Okay, and that would be discrete. With siblings, how many siblings do you have? With continuous, the grammar changes. So for example, weight. How much do you weigh? You don't say how many do you weigh, do you? I don't know if you ever thought about it. You know, when you grew up in America, I don't know if y'all grew up in America or not, but we just like take grammar for, like, we just know it because we've been born with it almost. It feels like it. But continuous answers the question, how much? And discrete answers the question, how many? Because how many is, you can count them out. How much is not, it's measurable. How much you measure, and it could be any number, including any possible decimal or fraction. Does that make sense? So I like to use the grammar idea to figure that out. All right, we're going to do, if you have a continuous distribution, you cannot draw a table. Why can't you draw a table like we did for the discrete when I did a probability distribution table?
Too many things to list. You might not be able to list them all.
Yeah, except it not just might not, it's impossible. So it's even more than might not. It's by definition impossible to list. So you can't do that. So what you do is you do the other thing you do in math. So if you think about when you first learned graphing, you kind of started with a t-table, but that was just a guide. And then what'd you do? You graphed, right? So that's what we're going to do for continuous distributions. So for example, it might look like ooh, that's not a bad line at all. I thought I was going to not have an awful line. It might look something like that. And that would be the graph of the continuous distribution function. Does that make sense? One of the things to note is that if you want to find out the probability, let's say we had some numbers in here. Let's say this is a 2. And let's say that's a 5. If we want to find out the probability that an outcome is between 2 and 5, what we do is we look at the area. So to look at the area, uh-oh. Oh, I think I have to move this. There it is. The area between 2 and 5 under this curve is the probability of landing between 2 and 5. And there's something special about these curves. If you look at the total area from far left to far right, what do you think you should get? Any thoughts?
1.
What number should you get, huh?
Is it 1?
Yeah, 1. Because there should be a 100% chance that something's going to happen, right? So the total area is 1. So notice that probability is always less than 1, greater than 0. Okay? It could be equal to 0 or equal to 1, but it's always between 0 and 1. Okay, so if you want to find out the probability that you're between two numbers, you find the area under the curve between those two numbers. Just a big note is that for something like this is supposed to be kind of like a normal curve. This is very hard. And you should like very hard. Why should you like very hard? Any thoughts? Because it means you don't have to do it. It's too hard. It's too hard for you to do. It involves advanced calculus, which we're not doing. But the calculator can do it, and that's not so hard. So we're not going to start with this problem because you don't know how to find area of a curve that looks like this. What's the one thing that you know how to find the area of? Or you might know a few, but what's the first thing you know how to find the area of that when you were a child? Now I got to think way back in 3rd grade or so.
Like a square?
Yeah, square. I'm going to generalize a little bit of rectangle. Yeah, so a rectangle. So if you have a rectangle, then we can actually do this by hand without that much difficulty. Does that make sense? So if you have a rectangle, we can do this. So let's do a problem. So now that I've introduced it, we can actually do an example. So let me go ahead and erase this because we're not going to deal with those. We're going to let the calculator deal with those, but not today. That's a different chapter, which is chapter 6. So we'll get to chapter 6 and we'll do those, and we'll let the calculator do it. But for now, we'll be able to do the one shape that we know how to do. So let's do it. So let me go and do a little copy paste. And I don't know if I'll do all of these, but I have some. Maybe I'll just do a few. Just a second. Kind of long, so. Okay, hopefully I have room to do this. All right. Suppose that the time that students spend in the Math Center is uniformly distributed between 10 and 120 minutes. So uniformly distributed, as I mentioned a little while ago, that's going to be the rectangle. That means that if you take the shape of the distribution, we're going to have a rectangle. Any questions on that? Okay. So we're going to find a bunch of things. We're going to find the first quartile for the time it takes. And then, I don't know if we can see all this. We're going to say, let's suppose that we're going to be giving an extra credit to students in the top 8%. How long must a student spend to get extra credit? And then a few other things. Okay, but let's start out with uniformly distributed between 10 and 20. So I am going to, as you might guess, draw a rectangle, which I'll do my best on. All right, so that's supposed to be a rectangle. Then what I do is I'm going to label this bottom part to be 10. And then I'm going to label the right at 120. And we need the height of the rectangle. So we're going to start there. I'm going to call that H for height. How do we find, any thoughts on how we might find the height of the rectangle? Do you remember what I said about the total area? What should the total area be? Getting a lot of silence. It's what I said just about 5 minutes ago, not even 5 minutes ago, 3 minutes ago. What's going to be a total area of a probability?
1.
1. 1. The total area of that rectangle has to be 1. Is that clear? Any questions on that? So the total area is 1, but now let's see if you remember your 3rd grade math. How do you find the area of a rectangle in general? What's the formula?
Base time height.
Exactly, base times height. So we know that base times the height is supposed to be 1. So now we just do that. So what is the base? Well, how do you get the base? It's 120 minus 10. Is that clear? Times the height, which we don't know, that's h, equals 1. I should have mentioned that we are doing some algebra today, whether you like it or not. But the good news is it's very beginning algebra. We're not doing logarithms or any of the weird stuff that you might have not liked before. Okay, how do we solve for h?
Divide by 110.
Exactly. So we get h is at 1 over 110. Any questions on that?
I thought you said that the whole area under the curve was one and that the rectangle was just like a section of that.
So in this case, when we say it's uniformly distributed between 10 and 120,
Oh,
that means nobody comes in and leaves before 10 minutes, and no one's allowed to go after 100, stay more than 120 minutes. So maybe the center's only open for 2 hours, for example. Does that make sense?
yeah.
So when it's uniform, that's what that means.
Okay.
And so an example of uniform might be that sometimes time can be uniform, like the number of seconds, that you finish at, in terms of what the clock says, because no one cares about the number of seconds. There's a few things that are uniform. Mostly we're doing this so you can understand area is probability. That's the main point of this. Okay? But when it's uniform, the rectangle is everything. The other example I showed you a normal distribution, and that was the curve that was everything, right? So this is the rectangle is everything. All right, so now we're supposed to say, what's the probability between 30 and 40? So now what I'm going to do is I'm going to do some more drawing. And let's change this to, I think blue is a good color for that. So 30 and 70. And now let's type those in. Any questions so far? All right, well, remember what I said, probability is area, right? So we need to find the area between 30 and 70. Well, if you draw the picture I drew, we just have a smaller rectangle. Do y'all see that? And we use that same formula for the area of a rectangle, which is, what's the formula?
Base times height.
Base times height. So we're going to go area, which is the probability. So let's write down this in probability language. So probability that 30 is less than x is less than 70 is equal to the base times the height. And the base now is what? Of the blue rectangle.
40.
Yeah, 70 minus 30. So I know you could probably do it in your head, but I like to write out the steps. 70 minus 30, because that's the base, times the height, which we already figured out. That was the whole point of all that work we just did. Times 1 over 110. And that's 4/11ths, if you work that out. Any questions on that? Any questions? Okay, so now let's do the next question. Find the first quartile for the time students spend in the lab. Now you got to remember chapter 2. I'm going to do this to you a lot, by the way, is I'm going to bring in old chapters and make sure you remember the old chapters to be able to do stuff from the new chapters. So what is the definition of the first quartile? And while you're thinking, I'm going to draw a rectangle. I want to draw another one because the other one got too busy.
The first 25%.
Exactly. It means 25% is less than that number. Okay, so what that says is the following. Somewhere in here, I can draw that. And what does 0.25 correspond to? In one word or a few words. Any thoughts?
Quarter.
Yeah, that's what it is, but what out in the picture?
Know what you mean.
It's the area. It's the area of this rectangle. So 0.25 is not on the x-axis. 0.25 is the area. It's really hard to draw. That's a little better. So that's the area of that rectangle. We don't know the value. If we knew it, that would be the answer and we'd be done. In math, when you don't know something, what do? You guys remember? You call it x. Isn't that what you do in math? Whatever you don't know, you give it a letter. And the standard letter you give it is x. We still have 10 and 120. That doesn't change. Same distribution. And now it's time for a little algebra. The area is 0.25, right? But now remember, how do you find the area of a rectangle again? What's the formula?
Base time height.
Exactly. What's the base of this blue rectangle?
X minus 10.
Exactly, x minus 10. We're going to have to do some algebra here. X minus 10. The height is still going to be 1 over 110. That doesn't change. And the area is 0.25. And you've done this in algebra before. We want to solve for x. So what's the first step on solving for x?
Times by 110.
Yeah, multiply left and right by 110. And that gives us that x minus 10 is equal to 0.25 times 110. And then finally, to solve for x, what do?
Add the 10.
Add a 10 to both sides. Don't you wish all of algebra was this easy? This isn't too hard, is it?
So you put 0.23 instead of 0.2.
Oh, sorry, that was a typo. Sorry about that. Thanks for letting me know.
Mhm.
I'll tell you, typing and teaching and doing the computer and all at once is not that easy, I promise you. But I'm doing my best.
I think you need to invest in a drawing tablet.
Yeah, I'm pretty good with the typing though, and my handwriting's horrible. You wouldn't want to see that I do this on purpose. You wouldn't. The 3 isn't because of the drawing tablet, and it's just happened. But that's the thing I've learned is that if I do it by hand, it doesn't matter if I'm drawing tablet. You still can't read it. I have terrible handwriting. In elementary school, I got all A's and a C. My C was handwriting. So let's make that a 5. See if it'll let me do it. I'll throw in a 5 and just pretend that it's always been there. Yeah, it's kind of a 5-ish. Okay, so that tells us the x is equal to 10 plus 0.25 times 110. And I want to remind you, you always are allowed to have a calculator. Calculator doesn't do the thinking for you, but this is the kind of stuff you can throw in a calculator. What do you get?
37 and a half.
37 and a half?
That's what I got.
Yeah, I could do it in my head and double check with you guys. So, 7.5,
Yeah.
37. Yep, that's what I get. Except it's 0.5. There we go. 37.5 is what I get when I do it in my head. Maybe you did in your head too. I'm not sure. Any questions on this? Does that look about right, by the way? It's always good to go back at the picture and to see if it's a reasonable number. If you got a number like 350, you should worry. Does that make sense? Because you can't have 350 if you're between 0 and 120 always. So always look back and make sure your answer makes sense. Same thing with the probability. When you work out the probability, if you get a number bigger than 1, you made a mistake. Is that clear? So on the find the probability that questions can never be bigger than 1. You also can't get negative numbers. Doesn't make any sense. I'm not going to do all of these because it's already 8:15. Let's do this last one because it's nice and easy and quick, but it's interesting. What is the probability that a student spends exactly 25 minutes in the math lab? So first thing, is it possible that a student can spend 25 minutes?
Yep.
Yeah, if it's uniform between 10 and 120, then a student can spend 25 minutes, right? But what is the probability? What is the probability that a student can spend between 0 and 25 minutes? All right, let me give you the secret word right now for Flora's sake. If you're still there, you're still there. So if you can stay 1 minute more, I'll write down the secret word. Because we're almost done anyway. The secret word of the day is, oh, what happened? Ah, tried. One more time. Is rectangle. The secret word of the day is rectangle. Because when you're doing a uniform distribution, you have to draw a rectangle. Okay, and by the way, on the test, if I ask you a uniform distribution problem and I don't see a rectangle, I'm going to take off points. And if I see a rectangle and everything else is just wrong, I'm going to give you points. So the rectangle are part of the points of the problem. Okay, if I ask for a normal distribution, you give me a rectangle, that's not good. So you better see the word uniform, and it will be there if I'm looking for a rectangle. All right, so now let's continue on and find the probability the student spends exactly 25 minutes in the math lab. All right, so to do that, let's think about the picture. And as I mentioned, we're going to draw a rectangle. I'll make this one blue. Okay, there's a rectangle. And we're between 10 and 120. So let's put in some numbers. And then what I'm going to do is I'm going to look at that rectangle and I'm going to say what does it mean to be exactly 25? What's the lowest number you could be if you're exactly 25? It's a stupid question. That's a hint.
25?
Uh-huh. What's the highest number you could be if you're exactly 25?
25.
Exactly. Is that a stupid question?
In
So when I draw
retrospect.
the picture, but if you draw the picture, it'll be really clear what's going on. There's 25. Let's give it a number. Let's do it in yellow though. What's the area between 25 and 25? What's the base of that rectangle that I just drew? The yellow rectangle.
1 or 0?
It's 0. Because if the left-hand side is 25 and the right-hand side is 25, you do right minus left, 25 minus 25. So for part C, very easy question, because the probability, let's do it in a different color now. Black works. Probability that X is exactly equal to 25 is equal to 0. In fact, the probability that X is exactly equal to any number will be 0. Anytime you have a continuous random variable. Does that make sense? And it feels wrong because it can still happen, but the probability is 0 because there's an infinite number of possibilities and only one is 25. And 1 over infinity becomes a 0. That's what's going on mathematically. Okay, any questions on this probability question? All right, just a couple notes. I'm not doing every detail. You are responsible for watching the long video and reading the chapter. For example, I didn't get to the standard deviation of a uniform distribution, which is the square root of b minus a quantity squared all over 12, which you would probably never guess, right? But there's a formula. And the mean of a uniform distribution, that one's easy because that's just the average of the left and the right. So that's just a plus b over 2. So in this case, it would be 10 plus 120 divided by 2, which is 130 over 2, or 65. Okay, so you should be able to handle mean and standard deviation. And once you have that, you should be able to get z-score if you know mean and standard deviation. Any questions on that? So I'm not doing full examples because I try to not to make these webinars go for many hours. Okay. Some of you may want it to be longer, but most people don't want to sit here for 3 hours and listen to me talk. I think I'd burn you out. But again, you have the long video and you do need to watch that, and you have the book and you need to read that also. But maybe I should show you. Let me go ahead and show you something about the book. There's the book. So if you go to chapter 4, there's a whole bunch of sections. Okay, probability distribution function, mean expected value, we did that. Binomial, we did that. Done. Don't do any of the rest. Unless you just want to, but I won't test you on it. So you don't have to do geometric distribution, hypergeometric distribution, Poisson distribution. You don't need to do any of that. And these are just examples. Okay. For continuous variables, we only do the uniform distribution. You don't need to know this exponential distribution. So again, in the chapters, when you're reading, you're only responsible for the uniform distribution, the binomial distribution, mean and expected value. And that's it for the book. So I want to mention that we're doing a lot of skipping. If I did every section in the book, I would really have to go fast. and you would probably not learn anything because we'd just be flying. Okay, so that's just a note, is that we are skipping some sections. All right, so that's about all I have to say for this particular webinar. It looks like the 7 o'clock, at least for a bunch of you, is working pretty well. But again, I want to remind you, if you want a different time or a different day, you need to post in the Q&A forum. And I'll usually say good unless I see a lot of, no, that doesn't work for me. But you know what I mean? Other people are replying. But it seems like 7 o'clock is what you guys want. At least I got a few people wanting that. But again, and you listening on video, because you're the ones that you couldn't make this webinar. If you have a time that you can make that you'd rather do, let me know, and then we'll see if other people want it also. I try to switch back and forth between Mondays and Tuesdays, so I don't block any one person out for too many times. So my guess, unless I hear otherwise from y'all, is next week will probably be Monday. The only Monday I won't make it is Memorial Day weekend. For sure won't be on that Monday because I try to honor the holiday. So if you have any questions, let me know. I just want to check in with all of you. Do y'all have a partner for the project?
Yes, I do.
Yeah.
Okay. Are you all in threes?
Yeah.
Are there any of you that are a pair of two?
I am in a pair of two.
Okay, I forgot who it was, but if you go, please go to the project discussion forum. There was somebody that was pleading, please let me in. And, huh?
It was Kim Houston.
Okay, so you remember. Has she gotten anyone yet? I haven't had a chance,
No.
at least in a few hours. But if you can answer and let her in, she seems nice.
Cool.
And she'll do some of your work, make life easier for you.
Totally.
And again, try to be nice to each other. I don't want anybody like panicking because they can't get a partner because a pair of two won't let them in. So if you don't mind, contact her. Give her some work to do.
Will do. Thanks.
Great, great. And all of you are watching this as an archive video. Please make sure you have a partner. If you don't, you need to post on the discussion forum and plead, let me in, and I'll help. I'll help you find people. But if you don't post, I can't do anything for you because I don't know. But if you have questions now, this is a good time. Could be on the project or anything. And Lamar, I saw your mouth move, but you're on mute.
Oh, I didn't unmute. What was the word again? Sorry.
All right, I'll give it to you just a minute. It was, I'll just say it, rectangle.
Okay, thank you.
You know how to spell rectangle, right? Yeah, and that's because uniform distributions are rectangle shaped.
And the long video you're referring to, is that the 43-minute discrete distributions, expected value binomial probabilities? Is that the one?
That's one of them. I don't remember if it's 43 minutes, but that sounds good. Sounds about right. And there's also one, if you go, if you can find all of the videos, let me do a screen share for you. And let's do that again. That one. Because better is I can show you how to find them. So if you go to the Canvas site, and by the way, if you go to home now, I changed it around, so now it sends you the modules, which is the main thing. And just a minute, I gotta move things around. And if you go to this course information, I believe you can find it there. And you go to archive webinar playlist. Hopefully I updated it. Let's double check. If I didn't, I'm going to update it now. No, haven't updated it. So let me do that right now as we're speaking. Good thing is I can do that quickly. I can't see. There. Just a minute. Sorry about that. All right. Another way of doing it is, sorry about that. So there's an error to this. If you go to YouTube, that's one way of doing it too. You can search it, but this is it right here. And this has, I'm sorry, these aren't the ones. Actually, it's not, sorry, it is that one. I made a mistake. Let me get there one more time. It's not archive webinar playlist. It is, that needs to be fixed, but that's a different fix problem. If you go to week 3, because that's what we're in, and you'll see full-length video of chapter 4, that one there. And you'll also see full-length video of chapter 5. So whenever you go on to Canvas, look at the week we're in, and that's all the stuff you're going to be looking at. So if you go to chapter 4, that's the one you were talking about. And you click on that, and there's a long video. And is it 43 minutes? Probably, yep, 43 minutes, 30 seconds. And then, if you go to the chapter 5 one, this is a video on that's 33 minutes and 11 seconds. So they're not too long. It's not like they're 6 hours long or anything. Any other questions? Because as always, I'll stay with you guys until you're done asking questions. But if you have some, that's the whole point of this, is to be able to answer questions.
I have a question about like statistically significant.
Uh-huh.
I don't think I quite understand like the meaning of that in the context of like a problem. Like I get that it's less than, 0.05 value, but is that if a value is statistically significant, does that mean like the study was done right? Like for that other one, the 20% or whatever it was that saying that that is correct?
It's not a correct or not correct. If it's statistically significant, what that means is a red flag gets raised and we say something is going on. Not the study is bad. So let me give you an example. Let's suppose what's your major again? I'll give you one in your major.
I graduated, but I was a psych major.
You're a psych major. Okay. So if you want to find out whether counseling helps people get a job if they're unemployed. Okay? So what you're going to do is you are going to look at people who aren't getting counseling, and you're going to see what is the probability just nationally in terms of someone getting a job within, say, 6 months. Does that make sense?
Mm-hmm.
And let's say that probability was 25%. So then you're going to do a study, and you're going to give counseling to maybe 500 people on how to find jobs and what's your issues, whatever. I'm not a psychologist, but that's your thing, right? Okay. Then you're gonna wait 6 months. You're gonna see how many of them found a job. Got it? And let's say 27% found a job. So that's higher than 25%, right?
Mm-hmm.
But is it high enough to say that that the counseling was really helpful? Or maybe if you randomly selected that many people, that you would just get 27% sometimes. Do you see that?
Yeah.
Because out of a random error, sometimes you're going to get above, sometimes you're going to get below. So it's statistically significant if you say that sometimes is so unlikely to happen that a red flag raises. And then we're going to say, yes, I have evidence, we say statistically significant evidence to say that counseling is helping. Do you see that?
Okay.
But if you got the 27% and you had a probability of, say, 0.28 of getting the number that you got, then you say, that's no red flag. It could have just had, That could just be random chance. Does that make sense?
Yeah.
And then you say, I don't have any evidence to say that counseling is helping people get a job. Does that make sense?
Yeah.
And that's what it's all about. That's what this whole course is about. It's to be able to decide whether you have statistically significant evidence to say that what you thought was true is actually true.
Okay.
And you think that counseling is helpful. Does that make sense?
Yeah.
So that's what it's all about.
Okay.
And we're going to spend a lot of time on it. So if it doesn't completely make sense today, that's all right.
Okay.
If it doesn't completely make sense by the final, that's not all right. Because we're going to spend weeks and weeks on it. Okay, other questions? That's a really important question, by the way. It's the question of the entire quarter. And I'll spend the whole quarter answering it. Any other questions? And as always, if you don't have questions and you want to say goodnight, that's okay too.
Oh, sorry. I have another question. For when we were doing the like one variable statistics, what does a two variable look like again?
So on your calculator, you mean?
Like no, like in a problem, like because we had like we had like the x value and then we had the probability of x, and we put x in L1 and the probability of x values in L2.
Right.
What would it look like if there was two variable statistics, like for a separate?
You mean when would you use two variable statistics?
Yeah, like on your calculator.
All right, so let me give you the answer that's kind of blunt. Chapter 10.
What?
Chapter 10.
Oh, okay.
You have a whole chapter on it. So I know this is hard, but I have to tell you to have patience on this one.
Okay.
So in chapter 10, that's the entire chapter 10. We spent an entire week just doing that.
Okay, so we haven't gone over like when that. Okay.
No, only in the spreadsheet because the spreadsheet worked that well that way.
Okay.
Okay, other questions? And I promise you, we will get to chapter 10, but not for a long time.
I'm gonna say good night.
Okay, well, have a great night. And my guess is Monday and next week. But before then, please post on the project discussion forum. And don't forget all the other assignments, too. A bunch of little assignments this week.
Thank you, Professor.
Okay, thank you. And I'll be checking the Q&A and the project discussion forum pretty often all week. Saturday, I'm going to be pretty busy, though. We have a conference, and I'm the chair of the whole conference. So I'll check early morning and probably not the rest of the day.
Professor, I do have a question, but it's besides the class lecture tonight. I understand that our final exam is going to be in late June, I think on the 28th.
Yeah.
Transcripts are due on July 1st for UC schools. Should I be taking the final exam early in order to get the transcript in by July 1st for the UC schools?
All right, I got some bad news for you. So the bad news is I don't think the final exam date that you take has anything to do with when the transcripts happen. So here's what I recommend doing very strongly.
Okay.
And I'm going to try and work with you. Again,
Okay.
I don't want to be the bad guy, that's for sure.
Right.
See if you can call the college.
Okay.
And let them know your situation. And you might want to call the university also. Because here's the problem. The problem is our grades are due on the Tuesday after finals week, which is in July. I will have your grade well before that. But me submitting your grades in does not put it on the transcript. The college has to put it on the transcript. Does that make sense?
Yes.
So I've never done this before. I've never had anyone with a timeline like this, but it's important. And I'll do everything I can to help you and work with you. But it's out of my ability to put anything on your transcript.
Okay.
I submit grades to our office, and then the office waits until the whole college has submitted grades, and then they put on transcripts. But maybe they can make an exception for you.
Okay.
And if not, maybe the university can make an exception for you. If you tell them that you're on the quarter system at Lake Tahoe Community College, and they finish on the 29th of June, and it won't show up on the transcript until like July 3rd or something like that. Does that make sense?
Yes, it does.
I will make sure I'm ready. One thing about me, and you haven't known me long enough, but I'm the opposite of a procrastinator. You notice like everything is already up there online for you for the entire quarter.
Right.
That's how I do things. I will grade your exam. And if you let me know that you need it extra early, I will grade it within probably an hour of when you take it.
Okay.
If your proctor gets it to me. I mean, obviously I have to get it.
Right.
Unless I'm like teaching during that hour, but definitely within a few hours, if I know that it's that important.
Okay.
Okay. But you need to make that phone call, because if you don't, then it probably won't happen.
You got it.
Okay. And talk to them. I will do whatever it takes to work with you and make sure that that's not going to be an issue.
Okay.
Okay. And my guess is that somebody on one side or the other will figure out a way to make it work.
Okay.
But if you don't do anything, it won't work. That's almost for sure.
Okay.
So sorry about having to deal with all that.
No, it's okay. It just, I'm sure, I've attended Lake Tahoe Community College 2 years prior, and everyone's been so fantastic. And I know I'm just starting to take your class now, but I've heard about you in my 2 years there. So it's been really great, and I'm so thankful I have you. So
good. So you're a long-term student.
Yeah. So.
Okay, good. You haven't had you before, so I don't know.
Well, I've heard about you through other students, and it's been really fantastic things. So
okay. And what UC are you going to again?
I got accepted into UCSB.
SD?
UCSB Santa Barbara.
Santa Barbara. Okay, great.
But I'm waiting for UCLA, and I think they're coming out this week. So.
Okay. I taught at UCLA.
I do know, yes.
And I got my degree at UCLA, my graduate degree.
Master's and PhD.
Right? Yeah. Excellent school.
Yes, my dad was a professor there.
Parking sucks.
Yes.
Just let you know that. Compared to Tahoe, parking sucks. Yeah. But the university has amazing things. Every president went there to give a talk, which was really cool. Yeah.
All right. Well, we'll see. I'll know this week.
Okay. Well, good luck. Although Trump doesn't like California, so he may not come to give a talk.
All right. We'll see. Okay. Well, thank you so much. I appreciate it. I hope you have a good night.
Okay. And just keep me in touch. Keep me informed on what I need to do, and I'll make sure it happens.
Okay. Thank you so much.
Okay.
Okay. Bye. Good night.
Okay, bye. And for all of you watching this as an archive video, thanks for watching. And please post on the Q&A forum or the project discussion forum, whatever is relevant, with any questions you have. And don't forget to watch the whole video and write down the secret word and do the secret word quiz. So have a wonderful night or day or wherever you are right now.